Okay, good morning. So today our discussion about fluid and particle mechanics will be go into the next part of lecture. And today we will discuss about fluid flow. So previously we have discussing about fluid in static manner, where the fluid in static condition they are not flowing, of course, it's static, and the parameters that influence the static fluid is only pressure. Please remember again the concept of hydrostatic pressure. It means the pressure experienced by the fluid because fluids, when it's contained in the container or in some confined by the solid walls, they will experience different pressure due to the height, the position. At certain position inside the static fluid will have different pressure, and any 2 points, two or more, any 2 points, when they have the same height compared to any baseline, whether it's in the base or maybe in the surface, any 2 points that have two same position and also connected with the same fluid will have the same hydrostatic pressure. That will be the concept. Ya, dua titik, dua posisi yang punya ketinggian atau kedalaman yang sama terhadap satu baseline ya. Baseline Anda bisa pakai dasarnya ataupun permukaannya. Kalau posisinya dua titik ini sama, kemudian antara dua titik ini terhubung oleh fluida yang sama, maka tekanan hidrostatiknya sama. Itu adalah konsep yang paling penting dalam hydrostatic pressure. Another concept that the position at that certain position, there will be the pressure will be influenced. Maybe I'll show this. So it's the surface. So these 2 points will have same hydrostatic pressure, and the pressure at this point will be the same or can be calculated by the pressure at this point, yeah, P1, then plus density of the fluid times gravitation times heat difference. P1 is the position at the liquid or any fluid surface. It means at this position, this point is also connected with the open air. If any point are connected with open air, the pressure at this point will be atmospheric pressure. Ya, jadi kalau titik itu atau posisi di situ terhubung dengan udara luar, itu pasti tekanannya tekanan atmosferik. Jadi walaupun masih ingat ya, you still remember the case when the fluid have this position. So even though this and this point, the position is not the same, so the heat is different. And this point are connected with different fluid. Ya, ini fluida 1, ini fluida 2. The pressure at this 2 point will be the same because both are connected to open air. This is another concept that you need to memorize or understand ya. Jadi walaupun dua titik ini tingginya tidak sama, kalau tadi kan tingginya sama, fluidanya sama. Kalau yang dua ini tingginya tidak sama dan fluidanya beda. Tapi kenapa tekanannya sama? Karena dua-duanya terbuka ke udara luar. So the pressure will be atmospheric pressure. I think that's the only concept that you will be using later when dealing with any static fluid. Another concept that you learn about how to derive force balance. Yeah, force balance. When you derive any balance, then you need to specify the volume or what we call control volume. Yeah. And the concept about force balance or later maybe mass balance or energy balance and defining the control volume, we will be still using it later in fluid flow discussion. Okay, so I hope you can understand the concept from the static fluid. Now we go to the flowing fluid or fluid flow. So fluid are considered flowing. I think the phenomena of flowing fluid you can imagine, right? Ya, fluida yang mengalir itu ya fluida yang bergerak terus. It means flowing fluid, the fluid undergo what we call continuous deformation. Ya, flowing fluid, fluida yang mengalir itu mengalami deformasi kontinu. So they change their shape. Deformation means they change their shape, and the change happen continuously. Yeah, why it can change the shape? Still remember. Please remember again. Sorry. Yeah. Please remember again. You can consider water, for example. It has. You can imagine water consists of several layers. So when you apply some forces to the top layer, we call it shear force. So the force that applied tangential to the surface of the liquid, we call it shear force. Then the top layer will be moving according to the shear force direction, right? And then the top layer will give shear force to the second layer, and then the second to the third layer, and so on. The amount of the force, of course, will be reduced. Yeah, when you analyze it downwards, ketika Anda melihat dari lapisan atas ke lapisan bawah, when you analyze from the top layer to the downward layer, the amount of the force experienced by the fluid will be decreasing, right? That's because of the friction force. So friction force basically the force that given by the liquid in order to against the shear force, ya. Jadi gaya gesek, kalau tadi gaya geser, kalau ini gaya gesek. Ini diberikan oleh lapisan fluida yang di bawahnya yang melawan shear force tadi. So the direction of the friction force will be in the different direction with the shear force. So they will be reducing the shear force and later reducing the velocity. So the velocity, the top layer is the maximum velocity, and then the second layer will be lower. The third layer will also be lower, and so on. And perhaps at the last layer, the velocity will be equals 0. So you can have this profile of velocity. And it happens continuously. So it's called flowing fluid. And it happens when the shear force are at the top layer, or the force experienced by liquid is at the top layer. Liquid can experience force from the middle, for example. We call it compression force. So, for example, you have liquid in the pipe, then you give pressure force perpendicular to the liquid. So it will give different velocity profile. So if the liquid experience pressure force, then the profile of the velocity, if you assume again it will be layered, then the profile of the velocity will be like this, right? Because exactly at the middle, the layer at the middle of the liquid will experience highest force, and then the layer on the top and the layer at the bottom from the middle, they will give friction force. Ya, jadi kalau gaya tekan itu ya, yang paling gedenya kan di tengah gitu ya. Misalnya paling gede gayanya di tengah, berarti yang kecepatannya paling tinggi ya lapisan paling tengah. Nanti lapisan di atasnya atau di bawah yang tengah itu akan memberikan gaya gesek. Sehingga makin ke atas atau makin ke bawah, kecepatannya akan makin berkurang. Same phenomena if you give the force from the top part. I mean from the, if the direction of the flow is like this one is the pressure force, this one is tensile force. Even though in the fluid flow it's very rare, ya. Bisa juga gaya itu diberikan dari bagian depan fluidanya. Jadi fluidanya ditarik. That's we call tensile force. So once we apply force to the liquid, we give either shear force, tensile force, or compressive force. The liquid or the fluid will go through the continuous deformation. And then the liquid will be flowing. Okay, any question first about this one? About the phenomena? I hope you can imagine the phenomena. Okay. So, when you apply force to the liquid or to the gas, or to the fluid, then the fluid will start to flow. And depending on how much the force you apply, and then how much the friction force or any resistant force that give back from the fluid, then the liquid will have a certain what we call flow regime. Ya, jadi ketika Anda memberikan gaya pada fluida, ya, besarnya gaya ya tergantung pada besarnya gaya yang diberikan, kemudian tergantung juga pada besarnya tahanan yang diberikan balik oleh si fluida tadi ya. Ini akan membentuk yang namanya regime aliran. We call it flow regime. So we will discuss two extreme of the regime. First is the smooth regime. We call it laminar flow. So laminar flow, the illustration is like the top figure. It consists of a very smooth layer, and then straight down the pipe, and then there will no mixing between layers of the liquid ya. Jadi tidak ada pencampuran dari layernya. Jadi layernya itu bergeraknya sangat-sangat smooth. At the center, the layer will experience very high or not very high maximum velocity. But as it goes through the piping wall, so this is the pipe wall. The top and the bottom one is the wall. The velocity will reduce, or sometimes at the velocity will be zero. Ya, jadi di pola laminar ini yang paling tengah itu kecepatannya paling maksimum, kemudian dia makin turun, ke sini juga makin turun, dan yang dekat dengan pipa kan tidak bergerak ya, the pipe is still, then the velocity at the pipe wall will be equal zero. Normally, this phenomena happen when the flow rate of the fluid is relatively low. The other extreme, when the flow rate is very high, the layer will not be as smooth as the laminar. So the mixing will happen, and then the velocity profile will be very, very chaos. Okay? So it's not as smooth as this one, but in the turbulent flow, we can assume, yeah, the phenomena is like in this figure. The mixing is very very high, so we call it turbulent flow. So at this condition, at this regime, then you can say that the velocity at any point is equal. We call it average velocity. So even though the profile is like this, but you can say if about the average about the velocity. So at any point across the diameter of the pipe, the velocity is constant. Ya, jadi kalau turbulen, walaupun profilnya itu chaos begini ya, nyampur-nyampur, pergerakannya mungkin yang seperti ini, tapi kita bisa katakan kalau pada profil turbulen, kecepatannya itu konstan, sama di semua bagian. Then how to differentiate? How can we say this is laminar flow. This is turbulent flow. Because we cannot do direct observation, right? Visual observation, then we can classify the flow regime by calculating the parameters called Reynolds number. Ya, jadi untuk menentukan apakah dia masuk laminar ataukah masuk turbulent, kita menggunakan parameter yang namanya Reynolds number. Perhaps you already heard about this parameter, so we will discuss it again. Okay, Reynolds number basically calculated by using this equation. So Reynolds numbers is the ratio, right, between density, yeah, rho is the fluid density, D is the internal pipe diameter. So please be careful, the diameter used is internal. Because later you understand, you know that diameter of the pipe will have inside diameter, outside diameter, because it has certain thickness, right? So the diameter is the inside diameter or internal diameter. And then the times velocity, average fluid velocity divided by the viscosity. So see, this is the basic parameters that used to calculate the Reynolds number. So basically, Reynolds number is the ratio between this one. The top part, the nominator, pembilang, is the inertial force. Ya, jadi pembilangnya itu adalah gaya inersia. The denominator is the viscous force, gaya viscous. The inertial force is the force that causing the liquid or the gas, the fluid, causing the fluid to flow. Gaya inersia itu adalah gaya yang menyebabkan fluida itu mengalir. Makin besar gaya inersia, the higher the inertial force, it means the flow of the fluid will be increasing. Ya, jadi gaya yang mempercepat geraknya fluida. At the contrast, the viscous force is the force that against the fluid flow. Gaya yang menahan atau gaya yang memperlambat gerakan fluida. The higher the viscous flow, then the slower the fluid flow. So it's the ratio. It means when the value is higher, yeah, when the value of Reynolds number is higher, then the inertial force is higher. It means the fluid will flow more freely, right? Because there is the influence of viscous force is low. Ya, jadi kalau Reynolds number-nya tinggi, artinya gaya inersianya lebih dominan dibandingkan gaya viskosnya. Yang atas lebih dominan daripada yang bawah kan, kalau nilainya tinggi. Artinya fluidanya bisa bergerak dengan lebih bebas. Yang nahan itu lebih kecil. So it will become, when Reynolds number is higher, it will become laminar or turbulent. Kalau fluidanya bergerak dengan lebih bebas, the regime will be turbulent or laminar.
Turbulent.
Yes. For high Reynolds number, it will be turbulent. Kebalikannya, when it's low Reynolds number, it means the viscous force is more significant. Gaya yang menahan gerakan fluida itu lebih signifikan. Jadi ditahan sama fluidanya. Gaya inersianya lebih tertahan. It becomes laminar. It becomes smooth flow. Okay, any question? Okay, for the, I think if you can see from the this figure, basically, you do not need to memorize the equation, but just understand that the profile for the laminar is like this. And basically, the profile for the, just a sec. Okay, the profile for the turbulent is like this, right? So fully turbulent will be like this. This is fully turbulent. So there will be shift in profile from the laminar to turbulent. This is the laminar, this is fully turbulent, and this is the transition. Okay, for the laminar flow, this one, the maximum will be at this point, right? We call it center line velocity or maximum velocity exactly at the center. And then at the wall, the velocity will be 0. And the profile is hyperbolic profile, right? So we can correlate between velocity at any point. Small r means any point along the radius. 0 means at the center, and bigger r is at the wall. Ya, jadi R sama dengan 0 itu di sini, R sama dengan R besar itu di sini. So you can correlate by using this equation. Later we will use this when we discuss about friction. Yeah, this is the hyperbolic profile of the velocity. Depends on the position. So at any point, ya, jadi R kecil itu sembarang poin antara 0 dengan sampai R besar, you can use this equation. This is the pressure drop along the pipe. Okay, so by using this profile, so the maximum velocity at the center will be this one. At the center is the maximum velocity. You can use the data. Of course, you need to know the data of the pressure difference along the pipe length. dP per dl itu adalah perubahan tekanan per perubahan panjang. Jadi beda tekan sepanjang pipa. Harus tahu nilai panjang pipanya dan beda tekannya. Nanti di materi selanjutnya kita akan bahas bagaimana cara menentukannya. Ini untuk tahu dulu saja. So at the point, at the center point, at the max velocity maximum can be calculated using this one. And the average velocity, because it will have different velocity, right, across the diameters, then you just take half of the maximum velocity. Yeah, this is the calculation for the laminar. Okay. The higher the velocity, then the profile of the velocity will be different, right? So like the layer next to the center will have higher velocity, or maybe sometimes it will be the same as the center velocity. And basically the velocity profile is random. And then the calculation of average velocity for the turbulent is basically using this equation only. When is the volumetric flow rate, meter cubic per hour, this is the area, square meters. Biasanya ngitungnya tinggal pakai itu kalau untuk turbulent flow. Karena kan random ya, the velocity profile across R is very random. Then how to calculate the average velocity? You just divide the volumetric flow rate divided by the area. What area? Area of the pipe. Cross-sectional area. Luas penampang dari pipanya. Okay. Okay, this one I will skip for now to confuse to avoid any confusion. you can get this equation later when you discuss about like fluid flow in more advanced lecture, not in fluid mechanics. Okay, what is the boundary, or what is the batas, boundary for the numbers of the Reynolds number, where it can be classified as laminar or turbulent or transition? Well, basically, there is no exact guidance, like exact number. Sometimes people are saying that if the Reynolds number is below 2000, it will be considered as laminar. And if it's higher than 4000, it can be classified as turbulent. And in between, of course, is the transition. But sometimes Reynolds number lower than 1000 or higher than 10,000 is turbulent. But this one is roughly correct for any calculation. So if still below 2000, you can use laminar. You can assume it's laminar. But if it's higher than 4000, you can assume that it's turbulent. And later, the pressure gradient is tadi ya, dP per dl. This one is dP per dl. Later, we will see that if the profile is laminar, dP per dl will be equals to Q. So linear, ya. Q pangkat 1, itu kan linear ya. Berbanding lurus. Proportionally linear. Okay. If the turbulence flow, for the turbulent flow, it will be 1.8 until 2, roughly. The fully turbulent is 2. So like quadratic proportional. And then in between, of course, will be from 1 to around 1.8, or from 1 to 2. Okay, well, we need to identify the Reynolds number. So not only to identify, we need to calculate Reynolds number is not only to identify the flow regime, but later when we are dealing with the calculation of friction force. Friction is the one that inhibit the fluid flow, right? So the friction force is basically calculated or influenced by the flow regime. Yeah, the flow regime will influence the friction force. So later we will calculate what's so-called fending friction factor. Ya, jadi tidak hanya untuk kenapa kita perlu menghitung Reynolds number, itu tidak hanya untuk menentukan pola alirannya saja ya, tidak hanya menentukan rejim alirannya, tapi dalam perhitungan juga akan digunakan. Misalnya nanti kita akan menemukan yang namanya faktor friksi. Faktor friksi ini digunakan untuk menentukan gaya friksi. Friksi itu tadi sudah dijelaskan ya, sesuatu yang menghambat gerakan. Makin besar friksinya, makin terhambat gerakannya, artinya nanti energi yang hilang akan semakin banyak. Artinya kalau energi yang hilang semakin banyak, Anda harus memberikan suplai energi yang lebih besar. Kerja pompanya akan lebih besar, kerja blowernya akan lebih besar. Ya, the higher the friction, it means loss of energy is also higher. The higher of energy loss means you have to supply more energy in order to make sure the fluid is still flowing to the final point. It means you have to make the pump works higher, or the blower works higher. Then to calculate the friction force, you can use the friction factor, and this friction factor will be calculated by using the Reynolds number. Friction is not only comes from, you can imagine the friction comes from layers of the liquid, and also comes from pipe wall to the liquid, for example. But friction also comes from the fitting. Fitting, I think in the first week of the class, we have discussed fitting is basically pipe accessories. It can be used to join the pipe, to join different sides of the pipe, to branch the pipe, or maybe to mengatur itu apa? Untuk mengatur kecepatan aliran, ya, to adjust the flow rate by placing what we call valves. All are fitting, and inside fitting they can come across friction as well. Ya, jadi di dalam fitting, ya, selain gesekan dengan pipa, gesekan dengan bagian dalam fitting itu juga akan menimbulkan friksi, akan menimbulkan hilang energi. And how to calculate the friction inside the fitting is also a function of Reynolds number. Also, when later we discuss about the solid particle, we will encounter what we call drag coefficient, ya, coefficient seret. This also influenced by Reynolds number. So discussion about fluid flow will always correlated with Reynolds number. Okay, any question? Oke, suaranya putus-putus nggak di sana?
No, sir, it's clear.
Okay, good. Okay, then how about okay, maybe before we go to the next slide, I want you to imagine what will be the differences between if you have a pipe then you have liquid at certain velocity and gas at certain velocity. Okay, physical phenomena wise, right? I want you to imagine the physical phenomena. Will you have different phenomena between liquid and gas? Please remember again your high school concept maybe. Ya, kalau Anda mengalirkan cairan dalam pipa, ya, diameter pipanya sama ini. These two pipes have similar diameters, and then you flow the liquid and flow the gas at certain velocity. Will they have different phenomena when flowing inside the pipe based on gas and liquid characteristic? Berdasarkan karakteristik gas atau sifat gas atau cairan ketika mengalir dalam tempat tertentu, kira-kira ada bedanya nggak? Oke, 101, Ulaya.
Yes, sir. I think the gas will be they will move like more freely because yeah.
Because of the molecules.
Yeah.
Okay, good. That's correct. Is there any other phenomena that you can imagine? Maybe Jilan? If the gas flowing inside the pipe compared to the liquid flowing inside the pipe at certain velocity, will there be any differences?
I think it will be different, sir.
Sorry again?
I think it will be different.
Yeah, what kind of differences that you can find or you may encounter?
I'm not quite sure. Maybe I think the friction will affect it.
Okay, before we go to the detail like friction, is there any simple phenomena that you might think of? Maybe Kanzu? Hello, are you there? Giraldi?
Yes, sir.
Ya. Berdasarkan sifat gas dan cairan ketika masuk dalam suatu tempat tertentu, kemudian mengalir, will they have different phenomena when they're flowing inside the pipe?
Maybe the gas flows like more random, maybe.
Okay, not in terms of the molecules, but in terms of they are fitting in the pipe when they are flowing inside the pipe. Suppose you are flowing water, liquid water, and you are flowing air inside the pipe. Ada yang bisa membayangkan nggak kira-kira ada beda apa? Bergantung pada kecepatannya, bergantung pada seberapa. It will be depends on the velocity. Velocity is volume over time, right? So it will be depending on the how much the liquid, the water, or how much gas flowing inside the pipe. If you are flowing water, a lot of water, higher velocity of water, higher flow rate of water inside small pipe. The water will be fully occupied the pipe, right? The whole of the diameters will be fully occupied by the liquid, the water. Ya kan? Ya. Kalau volumenya itu sangat-sangat tinggi, pipanya relatif kecil, maka seluruh bagian diameter ini semuanya akan terpenuhi oleh air. Vice versa, but if you have smaller flow rate, but you have a higher diameter of the pipe, what will happen? The water will not fully occupy the pipe. Ya kan? Berdasarkan sifatnya, ya karakteristiknya ya, kalau volumetric flow rate airnya itu kecil, sementara pipanya itu gede gitu ya diameternya, kan dia nggak akan penuh ya. Mungkin hanya mengisi, maybe it's only fill half of the pipe. Maybe only fill a quarter or 3/4. How about gas? Air. If you flow the air into the pipe, no matter how much the velocity or the flow rate, or no matter how big the diameters, the air will be fully occupied the pipe, right? You can imagine the differences, right? So the gas will always fully occupy the pipeline, even though the velocity or the flow rate might be small or the pipe is big. But for the water or for the liquid, the gas will be different depending on the flow rate or depending of the gas of the pipe diameter. Sometimes it will fully occupy the pipe. Sometimes it's only fill part of the pipeline. Now, especially for this water or liquid, the calculation of the Reynolds number will be different because you remember, right? Reynolds number will be density of the fluid, diameter of the pipe, velocity of the fluid, and viscosity of the fluid. So this one is the fluid properties. But this one, density and the viscosity is fluid properties. Diameter is the pipe properties. Velocity will be the fluid properties, but it's not properties actually, it's parameters that also it will be depending on the pipe diameter as well. So you need to consider what will be the diameter and what will be the velocity when the water is not fully occupied the pipe. Ya, jadi ketika ini hanya berlaku untuk cairan ya, fluida cair. Karena kalau fluida gas kan selalu mengisi penuh pipa. Tapi kalau fluida cair kan tidak selalu. Nah, kadang dia penuh, kadang setengah, kadang seperempat. Nah, perhitungan Reynolds number ketika kondisinya tidak penuh, itu harus hati-hati. Karena nanti akan berpengaruh di nilai diameter dan di nilai kecepatan. Ya, it will be influence the diameter and the velocity. So in this context, or maybe if the pipe is not cylindrical, right? So the area is not circle, sometimes you encounter rectangular pipe or maybe triangular pipe. So the calculation of the diameter will be different. Okay. Now we relating to that phenomena. you need to understand what we call perimeter. Ya, kalau alirannya itu tidak penuh, ya, tidak penuh mengisi pipa, atau bentuk penampang pipa, ya, the cross section of the pipe is not circular, then you need to define what we call perimeters. Perimeters is length of the wall that in contact with the fluid. Jadi panjang dari bukan panjang pipanya, ya, tapi panjang dari dinding pipa yang kontak dengan fluida. It means if you have circle pipe, if you have rectangular pipe, and for the gas, or if the liquid are fully filling the pipe, the perimeter will be this length. For this one, the perimeters will be this length. But if the liquid is only filling the half of this one, or half of this one, the perimeters will be only this one. This one is same, only this one. You can see the difference, right? Ini yang disebut dengan perimeter. Panjang dari dinding yang kontak dengan cairan. Ya, jadi kalau penuh, ya, sepanjang area ini, sepanjang lingkaran, ya, sekeliling lingkaran atau sekeliling kotakan. Tapi kalau setengah, ya, hanya setengah keliling. Ini hanya setengah keliling. Kalau sepertiga atau 3/4, ya, segini gitu, ya. Ini juga segini. Yang ini tidak dihitung, ya, karena dia tidak kontak dengan dinding. Jadi hanya yang nempel ke dinding. That's what we call perimeters, or sometimes weighted perimeters. Nama lengkapnya weighted perimeters. The full name, perimeter terbasahi. So for the gas, the perimeter will always be the cross section of the pipe, karena gas selalu mengisi penuh. But for the liquid, the perimeter will be depending on the fullness of the fluid in the pipes. For example, it's like this one. Yeah, the pink color represent how much the water or the liquid filling the pipe. So this one is the perimeters, and this one is the perimeters. Ya, jadi perimeternya ini, yang ini hanya yang ini. And how to calculate diameters? Diameters is basically this is the perimeters, ya. Keliling tadi itu adalah perimeter. Bagaimana dengan diameter? For the diameters, we calculate what we call equivalent diameters. This is diameter equivalent, where the value is 4 times hydraulic radius. Ya, diameter ekuivalen itu adalah 4 kali radius hidraulik atau radius ekuivalen atau diameter hidraulik, ya. Diameter ekuivalen itu disebut juga diameter hidraulik, 4 kali radius hidraulik. What is radius hydraulic or hydraulic radius? Is the cross section area divided by the weighted perimeter. Which one is the cross section? Cross section is this one. Area. This one. Which one is the weighted? Weighted is the circumference. If it's fully, if not, just this one. Okay, if you have a fully filled pipe, then the cross area, luas area lingkaran, apa rumusnya? Luas lingkaran.
Is
You
it
still remember?
VR square, sir?
Yes, PR squares. Okay, how about the weighted perimeters? How about the circumference of the circle? Keliling lingkaran. Pakai R, ya. Kalau tadi luasnya sudah pakai R, keliling pakai R juga. What will be the formula?
2 pi r.
2 pi r. So what will be the equivalent diameters? Then you just this one. Diameters will be 2r, which is called diameters, right? So if the liquid is fully filled the pipe, then the equivalent diameters will be the same as circle diameters. That's the case for this one. But for the second one, you need to calculate the area, and then you calculate the weighted parameters. It will be different, unless for if the water filling half of the area, then actually the equivalent diameters will be the same as diameters, because half of the cross section is this one, right? And half of the weighted parameters is also this one. So it will be the same. Ya, jadi kalau cairannya mengisi setengah, diameter ekivalen tetap sama dengan diameter. Kalau setengah, karena yang atas dikalikan setengah, yang bawah juga dikalikan setengah. But that won't be the same case if the liquid are not filling exactly half. You need to do this calculation. Okay. And that's the case for the circle pipe. If you have any other pipe cross-section, then you can see from this figure, for example, this is the rectangular pipe. The case 1 and case 2 is fully closed cross-sectional. Ya. Jadi tiga-tiga ini sama-sama pipa dengan penampangnya kotak, tapi yang 1 dan 2 ada tutupnya di atasnya. Ini masuk ke dalam ya. So you can imagine the pipeline is going inwards the slide. So for the case number 2, it's fully filled. So the cross area is this one, and parameters is this one. Yeah, this is the equivalent diameters. How about the case 1? Case 1 is the case where the pipe is not fully filled with water. So the area is only this one. The weighted parameters is only this one. For this one, the area is this one. The weighted parameter is this one. For the third case, the area is this one. Yeah, same with the case number 2. However, the weighted parameters is only this one. You do not calculate this length because the pipe is not closed from the top part. Ya, jadi untuk yang kasus ketiga, luas areanya sama dengan kasus 2. Tapi weighted parameternya hanya sisi-sisi samping dan bawah. Okay, other case, this one. We call it annulus pipe. So double pipe, ya, pipa anulus itu 2 pipa yang konsentrik, kemudian airnya mengalir di antaranya. So the area will be this one. The weighted parameters will be the circumference of the small circle plus the circumference of the big circle. So you can calculate how much is the hydraulic diameters or equivalent diameters. The same. Hydraulic diameters and equivalent diameters is the same. Equivalent radius and hydraulic radius is the same. This one, area divided by weighted parameters, is hydraulic radius. Okay. Any question until this part? Okay, if you have no more question, or if you still have any question, then you can discuss it, I think, on Thursday. So thank you very much. I'm sorry for delaying the class today, and we see you on Thursday. Thank you and good morning.
Thank you, sir.
Good morning, sir. Thank you.
Much, sir.
Thank you, sir.
Thank you and good morning, sir.